Morning everybody, this is I Mohan Sai. So today we are going to discuss about one of the most important topic in physics, that is nothing but matter. So in general, when we talk to our friends or neighbors, we ask them what's the matter. So here in this physics, so that's not the thing. So here matter is as anything which occupies space, has mass, and can be perceived by our senses. So that means everything in the universe is matter. So what we told in definition means matter is anything. That means matter is everything. Anything means nothing but everything which has mass. That means it contains some weight, some mass, and occupies space. That means when there is matter, it occupies some space and can be perceived by our senses. That means we can sense matter by our senses. So what is matter means everything in our universe is made with matter. That means if we take this marker, we can call this as matter. If we take this whiteboard, we can call this as matter. And also when we take this stand, we can call it matter. That means everything in the universe is nothing but matter. So then what is this matter made up of? So matter is made up of very tiny particles called molecules. So what is these molecules? So molecules are very tiny particles. So when two or more than one molecules combine, matter will be formed. And there are also smaller particles than molecules, from which molecules are made up of. Those particles are nothing but atoms. So what are atoms means? Atoms are the particles, when combined they form a molecule. That means molecule is made up of atoms. Okay, so that means matter is made up of molecules, and those molecules are made up of atoms. So let us discuss about the characteristics of the molecules of a matter. Okay, this is molecules, characteristics of molecules of matter. So here the first characteristic is they, means the molecules of matter are very small in size. So that means these molecules are very small in size. Let me give you an example that how can you can imagine that how small the molecules are. So if we take this dot, so in this dot there are crores and crores and means millions and millions and millions of molecules. So that you can imagine that how much small the molecules are. So I will tell you one thing, that we can't see molecules with our naked eye, that means normal eye. So then how can we see the molecules means we can observe molecules under a powerful microscope only. We can't see these molecules with our eyes. So that means you can understand, right, how much small these molecules are. Then you can imagine how smaller the atoms are. So molecules are very small that we can't see with our naked eye. We can only see under microscope. Then how much smaller are atoms? So you can imagine that. So second characteristics, they means the molecules are in constant random motion. Discussed is matter is made up of so many molecules, right? So those molecules are not in a rest position. So they are in constant random motion. That means they continuously move from one place to another place. Okay, so that means they will not stay at a single place. And the third characteristic is they have spaces between them. So they means the molecules of matter have spaces between them. So what we discussed is matter is made up of so many molecules. So those in between a molecule and a molecule, there is a space, and this space is called as intermolecular or interparticular spaces. Okay, repeat me. Shall I repeat? So molecules of matter contains spaces between them, and this space is called intermolecular or interparticular space. So this is very important topic, because on this basis the three forms of matter depends on. So what's this called means intermolecular or interparticular spaces. Okay, and the fourth important point characteristics is they attract each other. That means the molecule and molecule attracts each other. They have a force of attraction. So this force of attraction is called intermolecular or interparticular force of attraction. Okay, so the spaces between the molecules are called intermolecular spaces, and the force of attraction between the particles of matter are called intermolecular force of attraction. I will write here intermolecular force of attraction. So on these 2 points, the the forms of matter will be depending on these 3 and 4 points. So these two are the most important points that we have to remember when we study about matter. So that is the intermolecular spaces and the intermolecular force of attraction. So now let us discuss about the forms of matter. So in general, we daily see 3 forms of matter, and we daily use 3 forms of matter. So those forms of matter are nothing but the first one is solids, and the second one is liquids, and the third form of the matter is nothing but gaseous state. So these are the 3 general states of matter what we see daily. So what is solid? So this solid is defined as a form of matter with a definite shape and a definite volume. So what is the example of solid means? A rock, a wood block, and this is also a solid because it have a definite shape and it also contains a definite volume. So then what about liquids? So liquids means they don't have a definite shape but they have a definite volume. So liquids take the shape of the container to which they are kept. For example, so some examples of liquids are water, milk, juice. So let us take water. So if we pour water in a glass, so that water takes the shape of that glass. Okay, so in place of water you can take any liquid. Any liquid is poured into a container, that liquid will take the shape of that container. So examples of these liquids are water, milk, juice. And what about gases? Gas is a form of matter with either a definite shape nor a definite volume. That means gases neither have a definite shape nor have a definite volume. So some of the examples of these gases are air. So in our surroundings there will be air. So that is an example of air. And nitrogen, oxygen, carbon dioxide, these all are gases. So then how can we classify these three forms of matter means? So I have told you in the characteristics of matters in that last 2 points, that is intermolecular spaces and intermolecular force of attraction. So basing on those 2 points, that means characteristics, these three forms of matter are classified. So in a solid, the molecules are very closely packed, and in a liquid the molecules are placed slightly with a gap in the middle, and in gases they are placed at very far. That means in liquids we have more intermolecular force of attraction and less intermolecular spaces. So that means so that's why the solids are in fixed definite shape, because they have a very strong intermolecular force of attraction and very weak intermolecular spaces as compared in these three forms. So because of these intermolecular spaces and intermolecular force of attraction, this solid is in the form of solid. So that means intermolecular force is more and intermolecular space is less. So that's why it have a definite shape, and these particles are placed very close. That means they are like the spaces between these molecules of solid are almost negligible. That means they don't have when we see in microscope, it seems like they have no spaces between them. Okay. And liquids have more intermolecular spaces and less intermolecular force of attraction than in solids. That means the molecules are placed more further than each other. I said you right. So because of that, the intermolecular forces are more, and the particles gap having more, so the force of attraction is weak, so that the force of attraction of the molecules of liquids is less than in solids, and the intermolecular spaces is more than in liquids in solids. So what about gases? So in gases the molecules are placed very far and far from each other. I said you right. So and that result, the intermolecular spaces are more and more than in solids and liquids, and the intermolecular force is the weakest in the form of gas. Okay. So in solids, we have landed in solids. The intermolecular force of attraction is very strong, and the intermolecular spaces are almost negligible. And in liquids, the intermolecular force of attraction is less. So intermolecular force of attraction in liquids is less than that of solid, and the intermolecular spaces is more than that of the solid. In gaseous state, the intermolecular force of attraction is very weak, and the intermolecular spaces are very big between the molecules. So and now we are going to discuss about another important topic, that is kinetic energy and potential energy. So kinetic energy is energy possessed due to moving position, and potential energy is energy possessed by body due to rest position. This is how I can explain you in a simple way. In deep, we can explain that in kinetic energy means the kinetic energy is a form of a mechanical energy which is possessed by a body due to its motion. And that means the kinetic energy is energy possessed by a body when the body is in motion. That means kinetic energy will be only possessed by a body because when the body is in motion. That means when the body moves, it possesses kinetic energy. And what is potential energy means? Potential energy is also a form of mechanical energy which is possessed by a body when the body, due to its position or position of rest. That means when a body is not moving or at a height, it does not, when his body is not moving and when it is at a state of rest, it possesses potential energy. And when the body is in motion, it possesses kinetic energy. And for your easy understanding, I will give some examples of kinetic energy and potential energy. So for example, so what here discussed in kinetic energy is the energy possessed by a body due to its motion. For example, for kinetic energy is when a water flowing from a hill to down, that water possesses kinetic energy as it is in motion. And another example is a moving train, moving car, moving scooter, moving bike, moving cycle, anything. So any object which moves possesses kinetic energy. And examples of potential energy: a rock lying on the top of a hill which is not in motion possesses potential energy. And water in a water tank which is not in motion possesses potential energy. So when the rock is rolling from mountain hill to down, it possesses kinetic energy as it is in motion. And when a rock lying on the top of a hill without any motion in it, it possesses potential energy. So that what the conclusion is, if a body moves, it possesses kinetic energy. If a body moves, it possesses kinetic energy. And when the body does not move, it possesses potential energy. And there are also units and formulas for this kinetic energy and potential energy. So we can write this kinetic energy in a simple way, Ke, and for potential energy, Pe. So now the units for kinetic energy and potential energy. So for kinetic energy, the SI unit, SI means SI unit is joule, and SI unit of potential energy is also joule. So why these both are having the same SI units means, so I have told you before when explaining about kinetic energy and potential energy that those both energies are the form of mechanical energy, so that they both have a same SI unit, that is nothing but joule. And also there is another units called CGS units. So CGS units of kinetic energy is ergs, ERGS, and CGS unit for potential energy is also ergs. Okay, so joule means SI unit, ergs means CGS. So here the SI unit of kinetic energy and potential energy is joule. So this joule has a definition. 1 joule of energy is used when 1 Newton force applied on a body displaces it by 1 meter. That means when 1 Newton force is applied on a body and the body is moved by 1 meter, that is called 1 joule. So we also have the formulas to find kinetic energy and potential energy. The formula to find kinetic energy is half mv square, and the formula to find the potential energy is mgh. So here half mv square means, so half into m into v square. So here m means mass of the body, and V means velocity of the body. So velocity. So velocity is nothing but speed, but those both are not same. Okay, so for kinetic energy, the formula is half into mv square, where m is equal to mass of the body, v is equal to velocity of the body. And here for potential energy, what is the formula? mgh, where m is equal to mass of the body. So here m means mass of the body and g means acceleration due to gravity. Okay, and h means height of the body. Okay, so kinetic energy half into mv square, where m is equal to mass of the body, v is equal to velocity of the body. And in potential energy, the formula is mgh, where m is equal to mass of the body, g is equal to acceleration due to gravity, and h is equal to height of the body. So these two formulas are very important. So I hope you understand the formulas for kinetic energy and potential energy, and also the units for kinetic energy and potential energy. So here we have the relation between the SI unit and CGS unit of kinetic energy and potential energy. So what we have discussed is SI unit of kinetic energy and potential energy is joule, right? And CGS unit of potential energy and kinetic energy is ERG. So there is a relation between those two. If we want to convert energy given in joule to energy given in ERG, then we can use. So what is the relation between these two means? So 1 joule is equal to 10 to the power 7 ergs. So this is the relation between a joule and an erg. That means a SI unit and CGS unit of potential energy and kinetic energy. So in the video beginning, I have told you that the matter has three forms, that is solid, liquid and gas. So there is also another process called change of state. So that means the changing of state from one form of matter to another form of matter. So that is nothing but the change of state. So this change of state will be explained in another video. So thank you for watching this video till end. Please like this video, subscribe to my channel, and please share this video to your friends and neighbors, and keep supporting me. Thank you for watching this video.